Designing Lean System. Lean system or operations system that maximize the value added by each of a company's activities by removing waste and delays from them. Lean systems affect the firm's of internal linkages between its core and support team process and its external linkages with its customers and suppliers. Continuous improvement using Lean system approach. One of the most popular systems that incorporate the generic elements of Lean system is the just-in-time system. According to Taichi Ono, one of the earlier pioneers at Toyota Corporation, the just-in-time philosophy is simple but powerful. Eliminate waste and MUDA by cutting excess capacity or inventory and removing non-value-added activities. The goal of a Lean system are thus to eliminate these 8 types of waste produced services and products only as needed, and the continuous improvement the value-added benefits of the corporate operation. The JIT system organizes the resources, information flows, and decision roles that enable a firm to realize the benefits of JIT principles. 8 types of waste or MUDA. Overproduction, manufacturing an item before it is needed, making it difficult to detect defects and creating excessive lead times and inventory. Inappropriate processing, using expensive high-precision equipment when simpler machine would suffice. Waiting, wasteful time to incur when product is not being moved or processed. Transportation, excessive movements and material handling of product between processes, which can cause damage and deterioration of product quality without adding any significant customer value. Motion, unnecessary effort related to ergonomics and bending, stretching, reaching, lifting, and bulking. Inventory, excess inventory hides problems on the shop floor, consumes space, increases lead times, and inhibit communication. Defects, quality defects the result in rework and scrap and adding wasteful cost to the system in the form of the lost capacity. Rescheduling effort, increased inspection, and loss of customer goodwill. Underutilization of employees. Failure of the firm to learn from and capitalize on its employees' knowledge and creativity impedes long-term efforts to eliminate waste. The Japanese term for process improvement is Kaizen. The key to Kaizen is the understanding that excess capacity or inventory hides underlying problems with the processes that produce a service or product.
Close supplier ties. Because Lean systems operate with low levels of capacity, slack, or inventory, firms that use them need to have a close relationship with their suppliers. Supplies must be shipped frequently, have short lead times, arrive on schedule, and be of high quality. Since Lean system is operating with low levels of capacity, it means that it will need anything within their power to have a close relationship with their suppliers for them to have a better product and output. A particularly close form of supplier partnership through Lean system is the JIT2 system. In a JIT2 system, the supplier is brought into the plant to be an active member of the purchasing office of the customer. JIT also means just-in-time inventory system. It is a management strategy that aligns raw material orders from suppliers directly with production schedules. Small lot sizes. Lean system use lot sizes that are small as possible. A lot is a quantity of items that are processed together. Small lots can be juggled more effectively, enabling schedulers to efficiently utilize capacities. Small lots reduce variability in the system and smooth production. They enhance quality, simplify scheduling, reduce inventory, enable Kanban, and encourage continuous improvement. Process considerations in lean systems. Most firms using lean operations use the pull method, in which customer demand activates the production of a good or service. In contrast, a method often used in conventional systems that do not emphasize lean system is the push method, which involves using forecast of demand and producing the item before the customer orders it. Pull method simply means that when majority of the customer demands and wants the product or goods, the production process begins. While push method is forecasting what the customer wants and produce the goods beforehand.
Quality at the source. Quality at the source is a philosophy whereby defects are caught and corrected where they are created. The goal for workers is to act as their own inspector and never pass an defective unit to the next process. It is an approach to quality that places responsibility for catching errors in the hands of the operator or at the point of field. Jidoka presents a visual management system whereby status of the system in terms of safety, quality, delivery, and cost performance relative to the goals of a given fabrication cell or workstation in an assembly line is clearly visible to the workers on the floor at all times. It is also known as automation, a simple way of protecting your company from delivering products of low quality or defects to your customers. Pokayoke, mistake-proofing methods aimed at designing fail-safe system that attack and minimize human errors. For example, designing parts to be assembled in only one way is a correct way. Andon is a system that gives machine and machine operators the ability to signal the occurrence of any abnormal conditions such as tool malfunction, shortage of parts, or the product being made outside the desired specifications. It means a visual communication, typically using light to indicate the presence and location of any problem. Uniform workstation loads. A lean system works best if the daily loads on individual workstations is relatively uniform. Efficiencies can be realized when the load of the firm's resources can be managed. For manufacturing processes, uniform loads can be achieved by assembling the same type and numbers of units each day, thus creating a uniform daily demand at all workstations. It states that balance between operation is more important than speed, and ideally, we should never produce faster than the customer requirement rate. Takt time is defined as a cycle time needed to match the rate of production to the rate of sales or consumption. It is a maximum amount of time in which a product needs to be produced in order to satisfy the customer demand. Hijonka is the leveling of production load by both volume and product mix. It does not build product according to the actual flow of customer order, but level out the total volume of orders in a period so that the same amount in mix are being made each day. It is stabilizes production volume and variety by consolidating total number of customer order. standardized components and work methods. In highly repetitive service operations, quick efficiency can be gained by analyzing work methods and documenting the improvements for all employees to use. In manufacturing, the standardization of components increases the total quantity that less produce more than components. The standardizing components and work methods help a firm achieve the high productivity, low inventory objectives of a lean system. In a lean manufacturing environment, the standardized work is a key element to success and a tool that will ensure your improvement will be sustained. And by using a repeating set of work methods, the process is more organized and improvement opportunities become more apparent.
Flexible workforce is a workforce that can perform a variety of different functions, or it is a group of multi-skilled workers. And also, having a flexible workplace helps the organization to ensure quality at source. Whenever there's quality issue, the others can come and help because they were aware of all these different types of processes that are part. Automation refers to the process of automatically producing goods through the use of robots, control systems, and other appliances with a minimal direct human operation. And the automation is nag-help siya na mas mapadali yung pagpaprocess ng mga products sa 5S philosophy, a method of creating a clean and orderly workplace that exposes waste and make abnormalities immediately visible. Dahil dun sa 5S na yon, mas nakikita yung mga abnormalities sa isang organization. The first S stands for sort. It means that eliminate whatever is not needed by separating tools, parts, and instructions from unneeded materials. The second S stands for straighten. It means organize whatever remains by neatly arranging and identifying parts and tools for ease of use. The third S stands for shine. Clean and wash the work area and make it shine. Working in a clean environment enables workers to notice malfunction in equipment such as leak, vibration, and misalignments. The next S stands for standardize. Establish schedules and method of performing the cleaning and sorting. The last S is sustain. The idea here is continuing commitment. It's important to follow through on the decisions that you've made and continually return to the earlier step of 5S in an ongoing cycle. Total Production Maintenance, or TPM. A production control system which monitors the availability, efficiency, and effectiveness of a firm's machinery and equipment. In a particular, how well the machine meets the requirements of availability and that the machine is operational when needed. Efficiency is meaning that it produces no defect or non-conforming products. Designing lean system layout. It means it is a method of applying lean principles such as a complex product or process or system design step. One purpose is to eliminate waste and optimize value, and other objectives include improving design efficiency and reducing time taken to reach the final solution. One worker, multiple machine. One worker, multiple machine is usually employed in situations where production volumes are not high enough to justify a big production line involving a large number of operatives. One worker, multiple machine economies on the use of labor while enabling advantage to be taken of benefits of a production line operation. For example, the setup costs. The setup costs include the labor cost of preparing machines, the cost of new tools, and frequently higher strip rates immediately after machine reset.
Group technology. This manufacturing technique creates cells not limited to just one worker and has a unique way of selecting work to be done by the cell. The GT method groups parts or products with similar characteristics into families and sets aside groups of machines for their production. This GT method creates one or more worker in order to fulfill the task given by the cell. Value stream mapping. Value stream mapping, or VSM, is a widely used qualitative lean tool aimed at eliminating waste or MUDA. Waste in many processes can be as high as 60%. Value stream mapping is helpful because it creates a visual map of every process involved in the flow of materials and information in a product's value chain. It is a map that can be helpful to know the progress in the product's value chain.
Hi, you are viewing the first value stream mapping tutorial ever. This tutorial will teach you the basics of the value stream mapping, and at the end of these video lessons, you will be able to draw your first value stream map. The tutorial is made of video lessons that will cover the principal elements of the value stream mapping, and in the notes of the video, you will find bonus materials. Each video is a lesson. Let us start here with the first concepts. Why value stream mapping? The main reason is that if you focus on one process and not on the whole system, your customer could not feel the difference. Focusing only on one process is like to improve only the engine of a car by leaving the wheels deflated. So to improve your company, you have to focus on the flow and the value of the entire stream, and not only on one single point. Benefits of value stream mapping. It is a collaborative tool, can be understood by everybody, help you to focus where it counts. You can see both material and information flow. Where to start value stream mapping? There is no point to start mapping the entire company. It is important to start where you can get results quite immediately. So, the best place to start is where a customer is unhappy or on SKUs that give the company a significant income. For example, if the company sells the SKU 1234 that generate an annual income of $10,000 and the SKU 5678 that generate $500,000, I will strongly suggest mapping the second one. Okay, now you know why to use the value stream mapping and where to start. Let me now explain to you other points. 1. Map by walking with sheets and pencil. It is not a PC exercise. Walk the shop. 2. Map yourself entirely and starting from the end of the stream. This will help you to better understand the process. 3. Do not rely on the data in the system. Look for reality. Speak with people. 4. The point of the value stream mapping is not the map itself, but genuinely understand the process looking to material and information flow. 5. Draw the current state. Do not jump to conclusions. That's everything for now. In the next video, I will describe to you the first element of the value stream map, the customer demand.
Kanban System. One of the most publicized aspects of lean systems, and the TPS in particular, is the Kanban system developed by Toyota. Kanban, meaning card or visible record in Japanese, refers to cards used to control the flow of production through a factory. In the most basic Kanban system, a card is attached to each container of items produced. This card can be useful to the items that has been produced in order to know the record of each container.
General operating rules. First, each container must have a card. Second, the assembly line always withdraws materials from the fabrication cell. Third, the containers of parts must never be removed from a storage area without a Kanban first being posted on the receiving post. Fourth, the containers should always contain the same number of good parts. The use of non-standard containers or irregularly filled containers disrupts the production flow of the assembly line. Fifth, the fabrication cell never pushes parts to the assembly line because sooner or later, parts will be supplied that are not yet needed for production. Sixth, only non-defective parts should be passed along to the assembly line to make the best use of materials and workers' time. This rule reinforces the notion of building quality at the source, which is an important characteristic of lean systems. 7. Total production should not exceed the total amount authorized on the Kanban in the system. Operational benefits and implementation issues. First, lean systems can be coupled with statistical process control to reduce variation in output. However, this combination requires a high degree of regimentation and sometimes stresses the workforce. In addition, workers might feel a loss of some autonomy because of the close linkages in workflows between stations with little or no excess capacity or safety stocks. Second, in a lean system, workers and first-line supervisors must take on responsibilities formerly assigned to middle managers and support staff. However, this environment can be difficult to achieve, particularly in the light of the historical adversarial relationship between the two groups. Third, in some instances, the reward system must be revamped when a lean system is implemented. Labor contracts traditionally crippled a company's ability to reassign workers to other tasks as the need arose. In other cases, however, companies relocated their plants to take advantage of non-union or foreign labor. Fourth, to take advantage of lean practices, firms might have to change their existing layouts. Certain workstations might have to be moved closer together, and cells of machine devoted to particular component families may have to establish. However, rearranging a plant to conform to lean practices can be costly. Fifth, daily production schedules in high volume make the stock environments must be stable for extended periods. Lean systems used in high volume make the stock environments cannot respond quickly to scheduling changes because little slack inventory or capacity is available to absorb these changes. 6. If the inventory advantages of a lean system are to be realized, small lot sizes must be used. However, because small lots require a large number of setups, companies must significantly reduce setup times. And lastly, if frequent, small shipments of purchased items cannot be arranged with suppliers, large inventory savings for these items cannot be realized.